Kia ora. Here's a bit of a tricky one. So we have worked out previously that our molecular formula is C4H7OBr and that we have a carbonyl group and we do not have a carbon-carbon double bond. So if we draw our possible isomers, these are the ones that could happen. And notice we have an aldehyde option for the first three and we have a ketone option for the next three. And all six have 4 carbon environments. Because we have 4 peaks in the NMR, we expect 4 carbon environments, and that doesn't help us because all of these would give us 4 carbon environments. So now we look at the mass spec, and we see we've got a peak at 43. So that is, remember, a 3 carbon fragment or a 1 carbon fragment with a carbonyl. Now, none of these have a 3 carbon fragment. In other words, CH3, CH2, CH2, or 2 methyl groups on a CH. However, we can have a carbon with a carbonyl, so a methyl and a carbonyl, which is present here in number 5 and in number 6. We could also have the same thing in number 2 and number 3, because if you add up the 2 carbons, the 3 hydrogens, and the oxygen, you also get to 43. So although I've only said 5 and 6, I've excluded 2 and 3, and that is really because I'm looking very carefully, is it an aldehyde or a ketone? Now, this is borderline. It's sort of in between what we could get for aldehyde or ketone. So that is one thing lends itself towards a ketone. And the other thing is we don't have any clear distinctive W. So I'm going to go towards a ketone rather than an aldehyde. But if you argued the other way and say it's borderline, you could include those options as well. I'm just using this example to show that sometimes things aren't clear-cut. Chemists actually use other spectra to help decide. So there's our fragment for that one. Now we can look at other fragments. So if we look at this fragment over here, that is the bromine with a 2 carbon fragment, which is also again present in 5 and 6, but it's actually present in number 3 and in number 2, so it doesn't really help us. We can clearly cut out number 1 and number 4. So for excellence, we would accept either number 5 or number 6 because there's not enough other information there. And depending on how you argue, we could perhaps accept these aldehyde options. So just to show it's not necessarily clear-cut with what you're given, but you must try and support your choice of isomer. Kia ora.